Hi guys, we're going to do more story problems today, your favorite kind of problems. And these problems will involve the idea of ratio and proportion, which is one of the most important ideas in mathematics. And it's important in mathematics because it's important in life. This idea of ratio comes up all the time. For example, if you bake bread, you're going to want to get the ratio of flour to water just right. A big batch will have more flour and more water, but the ratio will be the same. And I think it's about 5 ounces of flour to every 3 ounces of water, or something like that. And we often write them as a fraction. So you would just say 5/3 is the ratio of flour to water. And you'll keep that ratio the same in different size of batches of bread. So let's go ahead and get started. Take a look at these. So here's our first problem. A 102-mile trip requires 8 gallons of gasoline. At that rate, how many would be required for a 235-mile trip? So let's approach this the way we approach story problems. We're going to read and reread the problem first. So read it again. A 102-mile trip requires 8 gallons of gasoline. At that rate, how many would be required for a 235-mile trip? Now we'll assign a variable, and we're looking for how many gallons for the 235-mile trip. And so we'll make that x. I think G is just a little harder to read. It looks like it could be a 9 or something. So we'll go with x. X equals gallons of gasoline for a 235-mile trip. So we've got our variable, and now we need to find an equation. We say find an equation because there's an equation in there. That's the way we're going to look at it. We just have to find it. This one you can find easily once you know some lingo, once you know what to look for. So I'm going to explain that. This says at that rate. Okay? Rate is short for ratio. And ratio is just a fraction of one number divided by the other number. So this says that there are two ratios that are equal here. You know, it has a ratio for the first one, 102-mile trip, 8 gallons of gasoline. Ratio is going to be the fraction, and we could go ahead and write that. 102 miles divided by 8 gallons of gasoline, the fraction. And I'm writing the miles. We don't really have to write the words miles and gallons there, but I'll explain why in a moment, why it might be a good idea to write that down. So that's our first fraction, that's our first ratio, and the story problem tells us at that rate, meaning the same ratio, same means equals, okay? At that same ratio, how many would be required for a 235-mile trip? So the ratio is the same for the other trip, and it's 235 miles. And what's the gallons for it? Well, that's x. We've already created the variable. Okay, so the two ratios are equal, and we call that a proportion when two ratios are equal or two fractions are equal. So we can solve this now. I want to mention why we wrote miles here. That's just to help us make sure we don't cross this up. We're saying the ratios are equal, but of course that is assuming we put the same number, the same quantity on top. If we put miles on top on the left side, we better put miles on top on the right side. The numerator should be the same quantity, the same units. So numerator is miles, denominator is gallons for both of the fractions. And by writing it down, writing the word, it might help you make sure you get it right. So we have the equation, and we'll just cross multiply and solve it. So when we cross multiply, we'll drop those words. We just had them there to help us make sure we didn't make a mistake. So this is going to be 102x equals 235 times 8. Well, that is 1,880 if you do it on a calculator. Okay, so now we just divide both sides by 102. And that is going to make, x is going to come out to be 18.4. And we have to interpret 18.4 watt. Well, it was gallons. So 18.4 gallons. And that's it. Okay. So let's look at the next one. John earns $350 in one day. At that rate, oh, I'm glad to see that phrase, because that means we're just going to have a proportion that we can set up. At that rate, how much money would he make in the month of October? Okay, so we're going to reread it. John earns $350 in one day. At that rate, how much would he make in the month of October? Okay, so we know how we're going to make our equation. We should set our variable first, though. That's going to be, let's use x again. X equals dollars he makes in October. Okay, now we've got a variable, and we can make our equation, and we know it's going to be setting two ratios equal to each other, two fractions equal to each other. So the one that we know both numbers for is for how much he makes in one day. That's $350. Okay, and we'll go ahead and put our dollar sign there over one day. Okay, and don't fret about which one you put on top. You could put one day over $350. Okay, as long as you did your other fraction the same way. So I think of this as dollars per day. So put the dollars on top is the way I did it. So that's the ratio of dollars to days. And for the month of October, we set our other ratio. We have dollars on top on the left, so we got to put dollars on top on the right, and that's X, right? That's how many dollars he makes in October. Now we have to have the number of days in October. So this is where you might have to get out your calendar. How many days are in October? 30 days has September 31, 28, except a leap year. But I believe it's 31 in October. So we cross multiply and solve. We take x times 1, that's x. 31 times 350, that is 10,850. I didn't leave room to write dollars there. 10,850, and that's what we get, and we write the units, which is dollars. And now we think about it, is that about right? If someone makes $350 a day, yeah, they're making pretty good money, and in a month it should be about that. So it's a number that makes sense, and I think it's correct. Okay, so these problems might look kind of difficult. You could probably figure it out without knowing this method of writing the fractions, but this really makes it a lot easier. Look for the phrase "at that rate," and that's telling you the ratio is the same. You can set the equation, which is also called a proportion. When two ratios are equal, that's a proportion. And you solve it the way we solve proportions when we learned that back in earlier in the year. Okay, so that's all for today. See you later.